Welcome back to the discussion on database normalization or creating our logical entity diagrams. If we now analyze what we have here as far as the database division that we created, now we have a dimensional database system. It's no longer in a flat file or a one file format. Let's perform a scenario to this particular instance. So if we were to pick up one of the orders, given the format that we have now, what can we find out about this order? Well, let's take a look around the databases. And car ID, let me change that. That car ID is a primary key. Okay. Transaction ID is only propagated over into the transaction cars. So we have a link between transaction ID and this transaction cars entity. What about these other ones? Well, we've lost information about these other tables. So what we'll have to do is create something called a foreign key. And it's basically a reference link that exists in the other tables. For instance, with client, if I want to link client to discount, I'll need to create member level, I'll write level, and we use a designator, and I'll put it here, FK. So this is going to be a foreign key, FK there. Let's take a look at car ID. What is car ID dependent on? Well, car ID has a dependency already. It's linked back here to transaction cars. So we're okay there. What about the client itself? Well, the client doesn't have any information about the transaction. So the transaction wouldn't know from the client master table which client to pull out. So we would need a, looks like it's a client num. So client num, and that's going to be a foreign key. So that will create a relationship over to the client table. So if we were to take an analogy of these entities being bolted to the side of the mountain, so the key one that gets bolted to the side of the mountain is this booking transaction. Is client connected to the side of the mountain, or is it going to fall down because of gravity? Well, let's take a look. Client number here is pointing over to client number in the client table, and then these attributes are connected. So we're okay for client. What about transaction cars? It contains the transaction ID, primary key, it's linked back, it's connected, so it's not going to fall down. Car ID, since transaction cars is connected, car ID links back to transaction cars, it's not going to fall down. Discount, the member level, we just created a foreign key there, that's going to create a link to the discount, and since client is already connected to our main booking transaction, discount is not going to fall down. So at this point, our database third normalization is complete. So now you see that the database model that I have here has changed quite significantly. What I've done is changed it to an entity relationship diagram, or ERD, and the ERD is shown with one of these rectangular boxes, and we place a line through it. So I'll go ahead and do that for my other element I haven't done yet. So I'll go ahead and create a box. I'll scroll that so you can see it. And I'm going to put a line through the box here at the top, and the primary keys will go above the line. So in this case, for the member level, we'll call this member level, and that's a PK, primary key. And the name of this entity is discount. So I'll place discount there. And inside of discount we have the attribute discount. and that concludes creating the entities themselves. So as you see, I've moved the entities around a bit more just for the next part, where we're going to show the relationships between the common data elements. And what we do for this is, remember with my mountain climbing example, we had them all linked up so they don't fall down off of the mountain. We're now going to show this, and I'm going to go ahead and connect. So if we take a look at discount, well, what is the relationship that discount has with another entity? Well, that is the client. So we're going to create a link like this, and I'll try to get it a bit straight for us as best I can. Okay, now so I'll create that one there. Now cars, let's take a look at cars. Cars has a link back to Trancars, so I'm going to draw a link into here. And Transcars links to the original transaction, so I'll draw a link there. And client then links also to transaction. So none of the entities are on their own. Now that we've created the relationships between the entities, there's another term that we're going to use, and that is called cardinality. Cardinality. What's cardinality mean? Well, cardinality will tell us the quantities between relationships. And that's done using something called the crow's foot notation for this specific example. Call it crow's foot notation. And it's just a symbol that looks like a crow's foot. So how do we apply this? Well, we take a look at using one of these entities as a reference. And if we're looking at booking transactions, we have to say with booking transactions, well, how many clients can we have? Well, we can have one client. And every booking transaction is only going to have one client. So that's why we put these two double sticks. That means one and only one. We can't have a booking transaction with multiple clients on it. As well as looking the other way, clients, if we have a client in the client entity table, does it need to be on a booking transaction? Well, we could have a client that's not on any order. So that's 0. Now, we can also have clients that come in regularly to the store and rent the cars. And so how many clients can we see on orders? How many is many? So we put in the crow's foot notation there. What about discount? A client. Can a client be a member? Well, we have a rule that no, a client doesn't have to be a member, so we put a circle in there. But also, if a client is a member, how many? Only one. A client only has one discount level if they have it at all. What about going the other way? Well, looking from a discount point of view, a discount will be one and only one client. A discount will not have multiple clients. When looking at booking transactions, how many transactions can we have, or these transcar lines in an order? So a client can come in and they can rent more than one car. So at least one, but also how many? We can put many in. As for the cars, the transcars, looking back at the order, how many can we have? We can have, again, we can have many. But is it possible to have a transcar, if we have a booking transaction without any transactions on it, is that really a transaction? We're going to say no. So we're going to have at least one. So there's our one-to-many relationship there. Looking at transcars, how many cars do we have on a transcar line? Can we have 0? Well, no, we need to have a car in order to have a transcar line. So that's going to be 1 and only 1. What about cars? Cars, looking at the transcar line, cars, can we have one car? Well, sure, we can have one car. Can we have more cars in the cars entity table than we have on transaction? That means if we bring a new car in, do we need to use that car right away? No, we can put 0 in because we can have a car that's not yet on a transaction. But if we do have cars on transactions, how many cars do we have? We can have many cars on transactions. So in conclusion, we'll take a look and see if our entity relationship diagram has covered the 3 main topics that we brought up in the beginning of this session. One is, do we have candidate keys? The candidate keys have been identified, as well as we have selected the primary keys in each of the entities. What about normalization? Well, as you can see with all the entities, they are in a third normal form as far as we can take it for this relationship. So the entity relationship diagram has been completed, and that ends this tutorial.